Hey, what's going on, guys? Let's do this problem right here. This question is asking a reaction mixture initially contains 0.25 molar CO and 0.400 molar O2. At equilibrium, the concentration of CO2 is 0.15 molar. Calculate Kc. First, we have to write the balanced equation for this problem, and the equation that is related to these three molecules are this one, that is CO plus O2 gives us CO2, right? Now we have to balance this one. Here we have 3 oxygen, here we have only 2 oxygen. Now if I put 2 in front of this, we have 4 oxygen, 2 oxygen right here, and if I put 2 here, this is balanced right now. 2 carbon, 4 oxygen, 2 carbon, 4 oxygen, right? Now in order to solve this equation, we have to use the ice table, that is I is initial, C is change, and E is equilibrium, right? Initial concentration, we know that for carbon dioxide and carbon monoxide and oxygen we have that is 0.25, and for oxygen that is 0.400. Now this one is going to be 0, right? So this is 0. Since this is 0, the reaction is going to shift toward the right. So if it's shifting toward the right, what's going to happen is in the change we are going to have plus x. Since we have 2 in front of this CO2, this is going to be plus 2x, right? Now we have plus 2x, so if it's plus, these are going to be minus. Now see, we have one coefficient in front of this one, so this is going to be negative x right here, and this is going to be negative 2x. And then finally the equilibrium is going to be just the addition of these things. Now here if I add this together, 0 plus 2x, that's going to give us 2x, and this is going to be just 0.4 minus x, and this is going to be 0.25 minus 2x. Now here they have given the equilibrium concentration of CO2, that is 0.15, right? So we can use this information to solve for x. If I solve for x, I can find concentration for each value. That will help us to find the Kc, right? Kc is our main question. Here we are trying to find the each concentration, equilibrium concentration actually. So let's go ahead and find it. So here we are going to have, so Kc, equilibrium constant for this one CO2 is given, that is 0.15. So we know that 2x is 0.15. Now let's put CO2 right here. CO2 concentration, 2x is equal to 0.15, therefore x is going to be equivalent to 0.075. Now we can use this information to find out oxygen concentration and CO equilibrium concentration. Now let's go for the oxygen next. Oxygen is 0.4 minus x, so here we are going to have 0.4 minus, instead of x I plug this 0.075, and that's going to give us 0.325, right? And let's calculate carbon dioxide, carbon monoxide, right? Carbon monoxide concentration is going to be equivalent to 0.25 minus 2x. 2x we already know, that is 0.15, so we can just subtract 0.15 right here, and that's going to give us 0.10. Now we have the mole per liter for each of the molecules. Now we can use this information to calculate Kc. Kc equation is product over reactants. Here the product is 2 CO2, right? And at equilibrium we have 2x, so we are going to use 0.15. So let's plug that value, 0.15. And since we have this one right here, this 2 right in front of this one, we have to square this one. So whatever the coefficient we have, we have to square it, or whatever the value, we have to put it on top. Now in the denominator we are going to have 2 carbon dioxide and oxygen. Now carbon dioxide is 0.25 minus 2x, That one we calculated right here, that is 0.10. So let's put that one right here, 0.10. And since we have 2 in front of this one, we have to square it. And we have oxygen right here, we calculated that one, that is 0.325. That one only have 1 in front of it, so we just put 1. And if you calculate this value, you should get 6.92, and that's going to be our Kc value. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.